one, we want to present about our project is optimization and cost efficiency using linear program and minimum spending tree to maximize the profit and minimize cost in the production and distribution for Agroindustry Domain, a case study of Keripik, Bogor, Maju. So let me introduce my team. My name is Kina Pertayun and my name is Tentang.
My name is Maju.
Next. So I will explain about the background. Berikut is Keripik Bogor Maju is a small business in Cisarua, Bogor. It's produced cheap using 5 main raw materials. They are red skin cassava, white skin cassava, purple skin potatoes, bananas, and taro. The cost of raw materials per kilogram range from 3,500 rupiah to 7,000 rupiah, with an additional production cost of 2,000 rupiah per kg. The selling price per kg vary from 12,000 rupiah to 20,000 rupiah. So the profit is calculated by subtracting raw material and production cost from the selling price. Raw material stock is limit red skin cassava 100 kg, while white skin cassava 50 kg, and purple sweet potatoes 80 kg, banana 60 kg, and taro 70 kg. Optimal planning is necessary to maximize profit with the available raw materials. Next. So this is the problem statement of Keripik Bogor Maju. And there are 3 main issues. They are, first one is high cost of production and transportation. The raw material and production cost amount to 2,000 rupiah per kg with additional transportation cost of 1,000 per kilometer. The second one is product fragility. The chips are fragile, increase the risk of damage during distribution. Raw materials must have limited availability of key raw materials such as red skin cassava and taro 70 kg restricted production capacity. So to solve this problem, we need to clear and effectively the plan. So the plan should focus on improving the production and distribution and lowering the cost, and also have to keeping the quality of the product. Next. The objective of this project is to maximize profitability for Keripik Bogor Maju to optimizing production and distribution. Next. The scope of this project is focused on optimizing the operational aspects of Keripik Bogor Maju to enhance efficiency and profitability. This includes analyzing the availability and cost of 5 micro materials: red skin cassava, white skin cassava, purple skin potatoes, bananas, and taro. While addressing stock limitation, production costs including an additional 2,000 per kg for all chips types are factored into profit calculation. Distribution planning aims to minimize transportation costs 1,000 per kilometer and reduce the risk of product damage, particularly for fragile cassava chips. External factors such as marketing investment are included. Keeping the analysis focused on production and distribution optimization. So this table shows us that there are main topic of using PICOS frameworks. There is population. So all small business actors, especially the Keripik Bogor Maju SME, engage in food processing based on local ingredients such as cassava, purple sweet potatoes, banana, and taro. And the second one is intervention. Implementation of operation research techniques. There are 4. Linear programming is to determine the optimal production quantity to maximize profit. And the second one is transportation route optimization to reduce transportation costs and the risk of product damage. The third one is sensitivity analysis to evaluate the impact of change raw material price, production cost, and distribution cost profitability. The fourth one is multi-optimization recorded in the form of Excel archiver, files from technical documentation and implementation. The last one is statistics. Is small business located in Cisarua district, Bogor, Regency, West Java, focusing on cheese production, local ingredients, and distributing to multiple regional markets. The study involves observational material research, production costs, and distribution rules to maximize profitability and operational efficiency. Okay, so next we will explain with my friend.
Okay, so this is our methodology, which will be used to method. For the first one is the linear programming. So the linear programming aims is to determine the optimal production quantities for each types of the chips that we use to maximize the profit, and the crucial algorithms to identify the shortest path and the most cost-efficient distribution route. This method minimizes the transportation costs and reduces the risk of the product. Okay, next. Okay, so this is the raw material cost. Consists of the red skin cassava with 5,000 rupiah, white skin cassava with 3,500 rupiah, purple sweet potatoes with 6,000 rupiah, bananas with 7,000 and taro with 5,500 rupiah. And the selling price is the red skin cassava chips with 5,000 rupiah, white skin cassava chips is 12,000 rupiah, purple sweet potato chips with 18,000 rupiah, and the banana chips is 20,000 rupiah, and the taro chips is 17,000 rupiah. The stock capability is quantity. So the red skin cassava is limited to the 100 quantities, and the white skin cassava is 50 quantities, and the purple sweet potatoes is around 80, and the bananas is 60, and the taro is 70. Okay, so and the additional production cost is 2,000 per kilogram, and the transportation cost is 1,000 per kilogram. And then, so this is the one of the solving problems. So the proof of profitability is the consist of the raw material cost, or the production cost, total cost, revenue, and the profit. Okay, so the raw materials cost is consists of the quantities times with the raw material cost. For example, like the red skin cassava chips is the quantities is 100 times by 5,000, and it's around 500,000 rupiah. And the other production cost is consists of the 100 is the quantities times by the 2,000 is around 200,000, and the total cost is the sum of the 500,000 by the other production cost is 200,000, around is 700,000, and the revenue is by the quantities times by the selling price is around 100 times by 15,000, and the result is 1,500,000, and the profit is and the revenue and minus is the total cost. From the profit, we conclude from 1,500,000 minus 700,000, around 800,000. And the distribution challenge and the root of limitations is begin with the central review, PDA, and it's starting from this one to the shortest path from the tree is the pasangan Bogor, and goes to the B is from the to the C is the City Modern Market is the 3, and goes to the B to the pasangan Bogor for the distance is 4, and goes to the A for 2 the Istana Bogor, the distance is 2, and goes to the F is the Kebun Ayam Bogor is the 3, and goes to the G is Suryagata is 4, and the total distance is 21 kilometers, and the total transportation cost is by 21 kilometers, but the cost of the per kilometer is around 1,000, and around is 21,000, and the net profit is the total profit and minus with the distribution cost with 3,180,000 minus 21 millions and 21,000, and the result is 3,159,000. Okay, so so this is the constraints for linear optimizations. From the raw material consists of the red skin cassava with the 100 quantities, one skin cassava with 50, purple sweet potatoes is 80, and banana is 60, taro is 70. And the stock availability, yes, it's the same. And non-negativity constraints is like this one. And objective function constraints is the raw material cost consists of the 8000 x1 is the variable by the type of the materials plus 6500 x2 plus 10,000 x3 plus 11,000 x4 plus 8,500 x5 minus 21,000. And the transportation constraints is the total distance from the previous one is the 3 plus 4 plus 2 plus 3 plus 4 plus 5 is around 213 plus and 21 kilometers. And the distribution cost is the same. Okay, so this is the linear programming with simplex solutions. It's starting by this simplex equations. The variable plus the black and it's 100 x1. X1 I think is red skin cassava chips is 100 x2 plus s2 is 50 x2 plus s2 50 and etc. And the substituting values is the objective functions is around z is 8000 times 100 is the quantities plus 6500 times 50 plus 10,000 times 80 plus 11,000 times 60 plus 8,500 times 70 minus 21,000 is the total cost of the distributions, and the result is 3,159,000.
birthday.